Your face looks sleepy. No. It's just a joke. Yes, the first and maybe the half part of the second chapter is yes, you can say it's boring, but this is why we go very quick. We will have already finished the chapter, right?
Yeah.
But we have to know something in these two chapters.
Right.
Then let's say the origin of soil. It's also very simple. You just know those stuff. So in this chapter, we will discuss first the formation of various types of rocks, the origin of which are the solidification of melting magma in the melting of the earth, formation of soil by mechanical and chemical weathering of earth, and then determining of the distribution of particle size in a given soil mass, composition of clay minerals, and the clay mineral provides the plastic property of soil mass and the shape of various particles in a soil mass. From here, determination of the distribution of particle size in a given soil mass. This is very important in soil mechanics. This is the first physical property of soil, particle size distribution. You know that soil combines of particles, water, and gas. And particle is not only one shape. If you put it in, how to say, a photograph, a very, what's that? Yes, high precision photograph. If you enlarge a very large scale, then you can see different shape of the particle, and they're in different size. This is why we analyze the particle shape. We analyze the particle size distribution. How much of this size range? How much of this size range? Because different size of range will make soil different properties. Then first, let's see how soil comes from. Actually, soil are formed by weathering of rocks. So we have rock first, and then the rock under weathering or chemical force, weathering force. So it becomes soil, and then soil becomes rock again, and then rock becomes soil again. It is just like a circle. But where rock comes from? Rocks is from magma. You know magma, right? Yes, we have magma and we have igneous rock. Igneous, after transportation, erosion underwater, weathering, and it becomes sediments. In here, sediments is soil because all of the soil we call it sediments. And if we process sediment under compaction, sedimentation, or some other weathering or chemical forces, it will become sedimentary rock first. And the sedimentary rock can transfer I don't know how to pronounce this word, but it will, yes, a more stiff rock. This rock under weathering, this weathering is a weathering of Earth. Maybe you know that sometimes the Earth is very cold, and sometimes the Earth is very, very hot. So this rock can melt under a period of weathering and become magma again. So it is a circle. But this circle takes a very, very long age. It takes a very long time to become such a circle, right? So soil are basically formed by weathering of rocks, and the physical properties of soil are detected by the size, shape, and the chemical composition of the grains. So this is why we study grains at the very beginning, because the size, shape, and the chemical composition determines the physical property of the soil. There are three types of rock: igneous, sedimentary, igneous rock, sedimentary rock, metamorphic rock. There's three different rock, but we have igneous rock first, and then we have sedimentary rock, and then we have metamorphic rock. I just read this. I think you know that igneous rocks, how igneous rocks comes from.
Yes.
Maybe for some water. Just 1 minute.
You look more awake.
Yeah, it looks like you were just there.
15 more minutes, guys.
Yeah. Huh?
15
You
more
know,
minutes.
going down like
15.
15, bro. You see?
What's that?
You're sleeping again.
Oh, something interesting?
Yeah.
He's sleeping.
A sleepy guy.
Go ahead.
All right. I want to finish the first part of chapter 2. So we still got 2 minutes. Igneous. Let's say the types of igneous rock. The igneous rock have different type, but it depends on the rate of cooling. You know it comes from magma, right?
Right.
But the rate of cooling will make it different rock, different igneous rocks. And different igneous rocks have different composition. After the rock, under weathering or chemical forces, it will become different soil. Okay? So this is a different igneous rocks. It looks beautiful, right? Then let's see weathering. We know that igneous rock comes from magma. After magma cooling, it becomes different igneous rocks. And igneous rocks will under weathering. The weathering is, let's see, in here. The mechanical weathering or chemical weathering. We have two processes. The mechanical weathering can occur due to temperature change, erosion. For example, some rocks near to the sea because of the water flash again and again, and some chemical stuff in the sea water. So because of erosion and any other context relates to sea. I don't know how to pronounce it. This long word.
Disintegration.
Okay, thanks. But during this process, there is no chemical composition change. So the chemical composition didn't change. It's just because of weathering. For example, water or wind. Yes, it may break, but the components didn't change. It is still such a rock. The components that in here, you see, when we say the composition, it is the chemical stuff. That is the basic stuff didn't change. But the chemical weathering occurs due to the chemical reaction, where the minerals are transferred into new minerals. That is the composition change during the chemical weathering. Chemical composition change. The three important clay minerals, we usually say the mineral, relate to the plastic property of soil are kaolinite, illite, and metamorphic unit. These three stuff. And this three is very important. If in a soil, kaolin is the main component in clay, it will have a coating property. If elite is the more clay in a soil, then it will show elite properties. So clay mineral is the most thing to determine the properties, the physical property of soil, and later the mechanical property of soil. Here are some mechanical erosion due to ocean waves and wind. This is the ocean waves mechanical erosion, and this such a shape because of wind, right? And because of ocean erosion. So these are mechanical weathering. And here, this is the in situ mechanical weathering. As long as you coat the rock, you wet the rock, dry it again under the cyclic weathering, cyclic wetting, drying, and finally it will swell or shrink, and finally it will fail and break down into pieces. So this is a weathering. And after weathering, you see that the big rock you can't transport, or the wind you can't transport it. But after years of weathering, it becomes small pieces. Then it can transport by gravity, or by water, or by wind, right? You know the weather is changed on the earth. Sometimes here it is a sea, and maybe many years ago it is a forest, right? So those weathered rocks, it will transport maybe by water, by wind, by gravity, by different force, right? It will transport, and it will go and go, run and run, become much small particles, and maybe many years ago it becomes soil, become into very small particles. So it may be transported by ice, water, wind, and gravity. And soil that remains at their place of origin are called residual soil. It never transported to other place. These are called residual soil. If the soil transports are classified into several groups, those are groups for soil that transport to other place. But you see, they transport by different forces. Transport by wind, transport by gravity, sea, lakes, running water, right? So maybe by water, most of them becomes sand, right? And then soil will become sedimentary rock, and another kind of rock. Because this two rock is after soil, so we want to talk it. We want to talk it because we study soil and soil mechanics. Okay, this is how soil comes from. How soil becomes from a rock. First, we should have a rock, and then we need to have some force, weather force, right?
Right.
And we need to have transportation. Then we have soil. Then let's see the soil particle size. The soil particle size, depending on particle size, soil are classified as either gravel, sand, silt, or clay. We always define the soil into 4 different soil. These are all, we can call these are all as soil. Even sometimes you see it is a small pieces of rock, but we design as soil. Because actually in civil engineering or in geotechnique, we think that soil is a much big concept than rock. Rock is just part of the soil. Because when we say soil, we can say big particle, small particle. If the particle is very big, maybe big as a rock, then we call it rock. But anyway, we also can call kind of soil in very stiff, very big particles, right? So actually, soil is a much larger concept than rock. But we usually divide it into 4 different soil: gravel, sand, silt, clay, and their particle size is changed from big to small. For example, we say gravel. This here are the name of organization that is based on different code, different classification method. So we classify the soil into 4 groups, but they are all based on the grain size. For example, usually for the gravel, for the particle size higher than 2 millimeter, it's 2 millimeter. In here, the unit is millimeter. Higher than 2 millimeter, we think it is a gravel. We call it is a gravel. For sand, it is usually mean that those soil particles is within a range of. In China, we use this 0.05 to 2 millimeter. If the soil particle is within this range, we call it sand. And for silt, of course, it's even small. The particle range is from 0.002 to 0.05. And sometimes people use 75, but it doesn't matter. When you say the silt based on, you need to also mention the code you followed, right? And also clay. Clay means that those soil particles less than 0.002. It's much small. Clay is just like a flower plant. Flower plant is very fine, very small. So this is some particle size classification, and later we will use this table to do homework, maybe after next class. Let me see. Yeah, here. But we will stop here. Here's some classification of soil. These are gravel. These are gravels. Small pieces of, it seems small pieces of rock, right? Gravels. And here is sand. And this is silt. You see, when we say silt, the silt is, the particle size is between 0.002 to 0.06 or 0.05 millimeter. It's very small. But in here, you see there are some particles. It's big. It is just because some structure makes them together. What you need to do is just crush them, right? It is not a range of particles. When we say particle size distribution, it is the range of particles. And kaolin is a clay, a kind of clay. We say kaolin elite. They are kind of clay again. In here, those particles, it is not the origin particles. It is a lot of particles get together. It's just like aggregates.
Oh.
Who makes that noise? You.
Yeah, understanding.
All right. So you see, it's clearly different, right? Why sand didn't make such a aggregate? Why?
Because it's particular.
Why gravel didn't make a aggregate that is stick particles together? Why silt and kaolin can stick together? The space. There are also some space in here, but do you think that if you push them together, they will come together? Sand, yeah, there are also particle and particle. You can imagine that there are space, but if you push them together, it can't stick. So some soil can stick, some cannot. Why? Because of clay minerals. So we will talk about clay minerals next class. Because silicon and kaolin have clay minerals. They'll have some charge in the particle surface. This charge can attract another part of charge, so they can stick together. But sand and gravel, they have no mineral. They have no mineral. All right, we stop here and talk about clay mineral from next class on Thursday, right? Thursday morning, very early morning. Make sure that you can get up.
Okay.
Don't tell me. Don't tell me.
Yeah.